Hello, people of the internet. We're going to kick off Module 9, and we're going to be talking about fillets. What we want to cover here in beads and fillets are SMAW prep. Our objectives are explain how to prep for SMAW welding, how to strike an arc, identify safety practices related to SMAW, explain how to prepare the area and equipment for welding, explain how to strike an arc and respond to arc blow. Our performance task is going to be setting up welding equipment and striking arc. It's actually going to be more than that. I don't know if they're just talking about section 1, but eventually in this section we're going to also have to weld in position 1, 2, 3, 4 with 60-10 and 70-18. So take a look at the performance review in Schoology. Welding safety, maintain safety and prevent injury. Always wear the appropriate PPE. Safety is everyone's responsibility, and you want to make sure that you use all equipment as it's designed to provide maximum protection. So let's scroll down here. We want to talk about the glasses. Face shield, helmet lens must all have proper light reducing tint for the type of welding or cutting being performed. Never view an electric arc directly or indirectly without using a properly tinted lens. Where are we going here? We're going to talk about fire, explosion, and prevention. Keep oxygen away from oil and grease. We've covered this material before in both the core and in welding 1 early on, talking about how flammable pure oxygen, it's what we use in the oxyfuel, can be when it's close to oil or grease, so forth. So you want to make sure that you keep that clean. We want to talk about containers, tanks, barrels, keeping things clean, ventilation, work area ventilation. Let's go down there. Here we go. Cutting or welding operations involving materials coatings that contain chromium can produce toxic fumes. You might want to write that down. If I was asking you what kind of metal can produce a toxic fume, and I gave you a bunch of choices, and chromium was one of your choices, you might want to write that down. That chromium it produces a toxic fume. Okay, moving ahead, we're going to talk about some equipment setup. The welding station surface must be steel with provisions for placing weld coupons out of position. So you've got the provisions for placing out of position. It's similar to our booth. We've got the fixtures in there made out of steel, and you can clamp and get any position you want to so that you can properly prepare for and weld position 1, 2, 3, 4, 5, 6, even with the pipe. We've got all that in our operation. So we're talking about preparing weld coupons. Weld coupons should be 1/4 inch to 3/4 of an inch thick. Look over here in red. I'd pay attention to that. Weld coupon should be carbon steel, 1/4 to 3/4 of an inch thick. Use a wire brush or grinder to remove heavy mill scale or corrosion. So if you had a test question that said, what do you need to do to prepare a coupon? You need to make sure that you use a wire brush to remove heavy mill scale or corrosion, and they need to be between 1/4 and 3/4 of an inch thick. We're going to talk about steel for practice welding is expensive. Every effort should be made to reuse weld coupons until all surfaces have been welded. That's why we have the plasma cutter set up. We use different things out there to make sure that we don't waste metal. Welding a T-joint on both sides, cutting it out and reusing it again. With the amount of people that we have running welding machines and electrodes and metal, if we're not careful and recycle and be on the lookout for waste, we would run out of material with nothing to do at that point. We just go to class, and that's not my idea of a good welding program. Electrodes. You want to obtain a small quantity of electrodes. Electrodes are sometimes referred to by the term welding rod or simply rods. So what's a welding rod? It's an electrode. What's an electrode? It's a welding rod. You never want to store electrodes loose to roll around a table. We've talked about that many times in our lab. We don't put them on the table. Don't let them roll off on the floor. You ruin them when you step on them, plus you got to clean up the mess. So, and they also could be a tripping hazard. So if you notice it's in red, never store electrodes to roll around loose on a table. They may fall on the floor. and they can become a tripping hazard. Some type of metal container's got to be used to store your rods in as well, your spent rod. That's why we have the little metal cans all down the in front of every booth. That is a requirement. You got to have a metal container to put hot, used, spent rods in. I want you to store them on the tabletop so I can keep track of how many you burned, and then after that, they go into the can. Preparing the welding machine. Welders, you have to know how to verify that the machine can be used for DC welding. An AC welding machine can be used for DC, but an AC welding machine is used. You have to use 6011, 7018 electrodes. You have to verify the location. In other words, you got to know what you're going to be welding, so you know what kind of process to use. You have to verify that you have the right kind of power. You can't take one of these welding machines in our booth and plug it in your garage. You don't have the right kind of electrical hookup. It's an industrial 3-phase versus a single-phase 120, which most houses have. They don't have the 240s and the 480s. What we have here, you got to check for proper ventilation. Make sure your polarity is set up, DC electrode positive, and you got to connect a clamp to the workpiece. So those are all components of preparing your machine. These are some different parts of your machine we're all familiar with: amp control, polarity switch, on off, engine start. Some have 120 volt outlets on them. We have all kinds of different settings on the front and the back. This has some examples of other settings on the machine. And so we're going to move into ventilation. Let's talk about chromium, for example, is considered a carcinogenic risk by international organizations. So chromium, the second time we've talked about it today, you can't breathe that. Manganese is another one, but it's not going to be on your test, but you need to know that manganese affects the central nervous system. Chromium is a carcinogen. And although employers and organizations generally recognize the potential hazards, you must also take personal responsibility for your safety. In other words, sometimes employers don't know, or they may choose to look the other way. So you need to know what your limitations are and what the proper safety things are to make sure that you're not putting your body in a place where it's going to be in danger. Here's a good example of a guy that's got a fume extractor, plus he's got a ventilator here. He's got some on his welding hood, filter back here on the back. He's filtering his air, pumping clean air in so that he's not breathing any of this stuff that's being kicked out. It's not a thing unless you're dealing with dangerous metal. Striking an arc. Let's see. What number are we on? 1.3. Yeah, striking an arc. The general rule is that arc length should be the diameter of the electrode being used. So if you're using a 3/32 welding rod, you need to have a 3/32 arc length. If you're using a 1/8 inch welding rod, that's a little bit bigger arc length. But the arc length is measured from the end of the electrode to the core of the base metal. So how do you know how long arc length is? It's from the end of your welding rod to the metal that you're welding. The general rule is that the arc length should be the diameter of the welding rod that you're using. So you need to understand those are test questions. So let's go on down. We're going to talk about different ways of striking an arc. You've got a scratch method and you've got the tap method. And let's see, we're going to talk about arc length. There we go. This is your welding rod, flux on the outside. This stands for your metal. Arc length is 1/8. So if you got a 1/8 inch rod, both of these 6010, 7018, 1/8 inch. So you got a 1/8 inch arc length. Now notice that the difference in the flux. Here 7018 has more flux on it than the 7018 has more flux than the 6010. So it's going to look like you're closer than you really are when you're running a 7018. Very important, especially with the way that we battle arc strike on those T-joints. So we're going to talk about scratching method. The scratching method, here we go, highlight that, green. It's the easiest way to strike an arc and used by trainees. Similar to striking a match. End of the electrode is simply scratched along the base metal until you get an arc strike. When the arc's been established, the electrode is raised to the proper arc length. The tapping method in reds, I ought to tell you something, please pay attention, that's a test question, is the best method of establishing an arc when using a transformer DC welding machine. Scratching method leaves arc strikes on the base metal that are not allowed by welding codes. That's why you want to tap, so you're not doing that scratch. So the tap is better because scratch leaves arc strikes. You want to make sure you understand that. Why is the tapping method better than the scratch? Because scratch leaves arc strikes. Arc strikes are considered damage to the base metal and depending on what the welding code is, can cause for a rejected weld. Up and down, contact, establish your arc. Rod holders, controlling arc blow, going green, practicing striking. When practicing strikes on an arc, you generally experience these two types of problems. Electrodes instantly weld to the base metal. It's caused by keeping it without keeping it too close, have your amps turned down too low, and not moving along. The arc will extinguish. Let's see. Turn the page. Arc blow. In red, test question. Magnetic fields tend to concentrate in the corners, in deep grooves. Think T-joint, deep groove of the base metal. This phenomenon is known as arc blow. So when the current flows, strong magnetic fields may be created that concentrate in the corners. That's on the edges. That's your undercut. When the arc approaches these concentrated magnetic fields, it's deflected. This phenomenon is known as arc blow. Constant current machines, restriking cold electrode. Electrodes with missing flux are difficult to strike. The arc is struck, it's unstable, and will blow or wander. During this time, you don't have any shielding, so poor welds will occur. Code requirements sometimes mean that if electrodes chip missing crack must be discarded. You have to change out you have to grind the weld out if you're welding with damaged flux. Arc blows occurs. Try one of these methods to control it. Tack weld the pieces in the middle. Shorten your arc length and change the angle of your electrode. Change the position of the workpiece lead clamp. Reduce the weld current when practicing. May also reduce arc blow. Reusing a stuck electrode. Carefully inspect the end. Get the flux kind of cleaned up down there. You can use a file, or you can clip it with a pair of pliers. Especially noticeable on T-joints. Arc shifting or wandering. Let's see. Both of the currents are arc electrodes that are smaller, well, and gap. If the arc initially deposits materials on workpiece. Very good. And there you have it. That's the end of section 1. Here's a section 1 review for electric arc welding with a lens tended to 9 to 14 or 12 to 16. I believe we're 9 to 14. That's our answer there. That's going to be in your questions. And let's see, the electrode stubs should be disposed in a suitable metal bucket container right here. And what's left? With the tapping method of striking an arc, the arc is struck 1/4 to 1/2 an inch past or ahead. It's ahead. Those are your questions. All right, I believe that's going to wrap up section 1, and that's what we're working on this week. Next week, we're going to be looking at section 2, SMAW techniques. Good luck, everybody, and as always, if you like this content, like and subscribe. Please feel free to donate to my Patreon page. You can send your thousands of dollars to my Venmo account, and that's cool. And let's see, if you want a bonus for watching this video to the end, you can say, Tugwell, you're not getting money on your Venmo from me. There's your bonus. Don't tell your friends. They probably didn't watch this video. Send me a message in School of Jeep that says, no Venmo money for you, Tugwell. And I'll get you a little 5-point bonus to kick off this 6 weeks.